Alright. So I just think up to there you're okay and you understand what we have been doing. Therefore, we can continue. Now that we have this equation number 5, we have equation number 5. So we can say that the reflection factor or the coefficient, we are using something like a P, but not P. That is what we call the reflection factor or coefficient factor. Is supposed to be equal to R minus Z naught over R plus Z naught. And therefore, you can be able to see that is what we are having here. So actually, what we're supposed to do is just to note that now that we have replaced the coefficient, this one equals to this one, come back, you understand that we have our ER. But now before we go there, we can substitute this equation number 5 in the equation number 3. We add an equation number 3 somewhere, which is this one. That is ET, ER, EI. You see that ET is equals to ER plus instant voltage. We just replace this equation number 5 in equation number 3. I'm sorry for that. I think I need some more, but I can just continue as it is. So we are saying that this was equation number 3. We are supposed to substitute this equation number 5 to equation number 3. And you know very well that after substituting, we shall understand that our ET will be equal to, we have our EI, right? We have our EI. So that means we have our ET that is supposed to be replaced with, of course, we say that we have equation number 5, which is that one. After replacing, you understand that you shall be having EI into brackets R minus Z naught divided by R plus Z naught, then plus EI. And remember, EI is the instant voltage. Is the instant voltage. Just on the same, now that we have this and this, you can factor EI actually, because we have this EI and we have this EI, which is supposed to be into. After replacing, factoring this one, we are left with 1. Then plus R minus Z naught divided by R plus Z naught. If you are very keen, you can be able to see that. And that means you can find the LCM, and LCM is R plus Z naught, R plus Z naught. Now, this of course divided by 1. That means now, this one, R plus Z naught is the LCM of this one, and is being transferred there above. After now, you take this one, multiply by 1. You remain with the same, then plus R minus Z naught, close the bracket. Remember, outside you add EI. So that is what we are having here. Alright, you can be able to see that there is something that you can be observing, that these are positive Z naught and these are negative Z naught. And that means the positive Z naught and negative Z naught, they will cancel, That's like saying a plus 1 then a minus 1, you get a 0. And then the r will be having r plus r, and therefore that will give you 2r divided by r plus z naught, r plus z naught, and therefore et is very clear that et is equals to that one, and therefore the transmission factor, or maybe the coefficients, is supposed to be given by uh, 2r divided by r plus z naught, right? That is now our coefficient. You remember in your exam, by the way, you are supposed to note this. In your exam, you shall be told to find the transmission factor, or maybe the coefficient factor. That is the thing that you are supposed to be able to do. If you cannot be able to do that, then I think you shall not be ready for that question, which is a very simple one to do. So IR, before we said that IR is equal to negative ER over Z naught, and we said again II, that is the incident current, will be equal to the incident voltage divided by Z naught, and therefore it is very clear to see that we can also say, maybe we say that also from this one, you can make ER, which is this one, the subject of the formula. That means the Z naught will be multiplied by the IR, then it gives you that on the first part. On the second part, you are supposed to note that EI will be equal to I Z naught, that is by just doing a cross multiplication of this one, so that now the second side will be that one. You can be able to see that ER is equal to R minus Z naught divided by R plus Z naught, that is what we said. Then of course multiplied by the incident voltage. At the same time, there is something that I want to talk about here. We know that of course this is the factor, the coefficient factor, and this is what we have derived here. So we can say this one is equal to the coefficient factor, right, multiplied by the I naught Z naught, and therefore you can be able to know that the Z naught and Z naught can cancel, and therefore IR is equal to the negative the coefficient factor multiplied by the incident current. That is another thing that you're supposed to note. Another thing that you can do, we can also, from the previous, or maybe from the above what we have discussed, we concluded that IT is equal to ET over R, and II, that is the incident current, is equal to the incident voltage divided by Z naught. And therefore, you can just make the cross multiplication of this one for you to get ET is equals to IT multiplied by 3. Then we have EI, which is equals to I, the incident current multiplied by the impedance, that is Z naught. Alright? That means now, you know what we add for IT, then R, of course. If you can be able to replace that, you shall notice that our ET, that is now the transmission voltage, will be equal to 2R over R plus 2Z naught. Over Z naught. This is a Z, not 2. That is Z naught, which is supposed to be multiplied by EI. And therefore, you can go to the other side and make ITR as equal to this one, the tau. We have this another factor. That is just the factor that another one that we want to introduce, and that factor is just like just a coefficient. So you remember that we add this one for the IR, for the reflected, and now we want to have another factor which is now the tau for the transmitted. So those are just the factors that will be used, IR and IT. So we can say that IT is equal to that one, and therefore IT is equal to replacing the value of Z naught. Of course, you understand that Z naught we said will be equal to Z naught divided by R, and therefore that will give you IT is equals to I multiplied by Z naught over R, then multiplied by the I incident. So these are the graphs of the voltage and the current surges. These are the graphs of the voltage and the current surges when R is greater than Z naught. Now, voltage and the current distribution along the line is just as shown below, whereby now this side we have the sending end side. The sending end side now in our case is just like a power generation. Maybe a Kenya the Kenchen, that is Kenyan generation company, that is Kenchen, where now we are having the sending end side. Then the other side we shall be having a receiving end side, which is supposed to be on the other side. So now we have the current. This is from the wave that we had above. We have the current which is having the EI, and remember the EI is the incident voltage. And then we have the X, of course. Again, we have the I, the incident current, moving on this side from left to right. At the same time, we are having, again, it's very important to note the EI and EI. That is when we have the voltage and the current before arriving at determination. Again, we have the voltage and the current being expanded. Now we have the X, which is now moving from the left to the right hand side. So you can be able to see that EI and II is more expanded than the first one. That is now because of we are on a different position on the arrival at determination. So we say that the receiving end is just you as a client. Maybe you are having that voltage at your house. At the same time, it can be the substation of the Kenya Power, whereby now they are being used the transformers for the step down. Of course, they shall be receiving that voltage and currents. And therefore, you can also understand this after the arrival at the termination. There will be something that will be observed for both current. But let us now start with the current. After arriving at the termination, now we want to terminate the voltage that will be used. Now we have ET. ET is equal to EI plus ER. What does that mean? That means that if we can take the incident voltage, you add the reflected voltage, then it will give you the transmitted voltage. I think that one is very clear. At the same, we add the I, the incident current, which is supposed to be the transmission current plus the reflected current. But now, in this case, we just want to see what is the transmitted current. The transmitted current now from this, make this the subject of the formula, you find that it will be equal to the incident current minus the reflected current, and that's why you are seeing we are starting with I, then the law. I think that is very clear. That is very clear. Now, I want to talk about the voltage and the currents surges when R is less than Z naught. So we can say when the surge arrives at the termination, then the current in the resistance, is now greater than the surge current, that is I, and it means now the incident current is traveled or maybe prevented from the instant velocity, hence increasing by the reduced the inductance of the line. That means the current deficit, that is the current difference, the deficit is just that current difference that we are using for our negative. So the current deficit is therefore derived from the discharge of the line, capacitance at the termination, and thus reducing the potential at the termination. Now we take again the sending edge side. We assume this is our chemical, the generation company. Then we have our transformers or maybe the substations at the KPLC, right? So you find that there is that voltage that we are expecting, the currents from the maybe that power generation while at the Kenya Power Company. That means the voltage and the current does not change, is represented by this one. This is the voltage. Of course, we have this distance from the left to the right hand side. We have the current, which is the same. Before arriving at the termination, and also we have the voltage and the currents. That is now the incident voltage and the incident current. That one will be at on the arrival at the termination, and therefore the voltage, just as we have done on the side on the voltage above that we are doing, you can be able to see that instead of now the voltage, because of this negative, then it means we shall start with I, then go low. Yes, and then your X will now be moving from the right hand side to the left hand side, just as the same. Now that we are having the addition, it means that is what we shall have in. This one now moves again from the right hand side to the left hand side, and remember that is just after the arrival at the termination. And I just think that what we've done is enough, quite enough for today. So